Okay, let's move on to question number 6. A pilot in a seaplane flies for a total of 3 hours with an average velocity of 130 kilometers per hour north 32 degrees east. In the first part of the trip, the pilot flies for 1 hour through a displacement of 150 kilometers east 12 degrees north. She then flies directly to her final destination. Determine the displacement for the second part of the flight. So we're given that the total time taken is 3 hours and that the average velocity is 130 kilometers per hour north 32 degrees east. So we could basically find the total displacement traveled since we have the average velocity and the time taken. So we just do 130 kilometers per hour times 3 hours to give the total displacement, and then add on the direction. We're given the first displacement is 150 kilometers east 12 degrees north, and we're told to find the second displacement. Since we have the total displacement and the first displacement, we could just subtract the components, the x and y components of both of those two to get the displacement of the second part. So I'm gonna go ahead and do that. So I'm gonna go ahead and already find the displacement total. I've already gone ahead and done that. So that is 130 kilometers per hour times 3 hours. That gives you 390 kilometers north, 32 degrees east. Now I'm gonna find the x components and y components of this displacement. So then I can take those subtracted with the x components and y components of the first displacement, which will give the second displacement value. So I've already gone ahead and converted the total displacement. I've done 390 cos 58 because this is 58 degrees. This would be 32 degrees. Subtract that by 90 and you get 58 degrees here. 390 cos 58, 206.668 meters east. That's the total displacement in the x direction. And in the y direction, it would be 390 times sine 58, and that would give you this value. Next, we find the x component and y components of the first displacement. So I've gone ahead and drawn a diagram for that one. So let's assume this is d1, and we find the x component and y component. This is 12 degrees. So 150 cos 12 equals 146.722 meters east, and the y component of that would be 150 times sine 12, which is 31.19 meters north. Now to find the x component of the second one, we would have to rearrange the displacement formula I showed earlier. So displacement 2x now equals displacement total x minus displacement 1x. So that is 206.668 meters east minus 146.722 meters east. 59.946 meters east. Now we can find the y component of the second part. So to do that, we've already calculated the y component here for the total, and we can calculate the y component here for the first one. So we just subtract both values. So that would be 330.738 minus 31.9. 31.19. We have the x component and y component of the second displacement. So d2y, d2x. So now we can find the second displacement by using the Pythagorean theorem. Displacement 2y. So that is plus 59.946 squared. So it's the root of 93522.527, and that gives us 305.487 meters traveled. But remember that this displacement is on an angle, so theta. So we would have to find the theta angle first. So theta equals tan inverse d2y over d2x. Since you know tangent is opposite over adjacent, so do tan inverse of opposite over adjacent. So that is 299.548 over 59.946, and you get 78 degrees. So your displacement 2 is 305.49 meters east, 78 degrees north, or you can rewrite it as 305.49 meters north, 11 or 12 degrees north, 12 degrees east. Yep. So that is how you do question number 6. So all we've basically did is converted the total displacement into its x and y components, subtracted it with the x and y components of displacement 1, and then found the x and y components of displacement 2 used those to create a triangle, used the Pythagorean theorem, found the hypotenuse, and then found the angle, and that's basically it. Question number 6. So I might just go ahead and do one more question, and then we'll move on to the next unit.